supports are very beneficial for small support areas. Like, for example, you have to deal with 1 centimeter time 1 centimeter areas here. So it's not a big support area that you have to treat with, because the disadvantage of these rod supports is that they are not connected to each other, and so they are not very stiff in XY direction, because each of these pins can bend in the X and Y direction a bit. So the stiffness in XY is not pretty good, to be honest. But for areas which are pretty small and you do not have to deal with that amount of stresses, it's a very beneficial way to support. Normally they will look like that. So there are tubes which are located under the area, and the critical thing, or the thing that our software has to deal with, is to find a sampling which is good enough on these regions. And therefore we developed the sampler pipeline, and beginning with the mean point sampler, which is more or less detecting local minima inside the region and positioning one single rod underneath. This is important because when you think about the printing or the building up again, we have to position a single rod underneath every island which is coming up during the build-up, because otherwise a geometry will begin in loosened powder, and this is critical because loosened powder, the recoater will remove those structures when the recoater is moving over the base plate. And so this detecting of lowest points is very important. And this is the first sampler strategy that we are using here. So this would not be a sufficient support anyway. So that's the reason why we developed the next sampler strategy, which is a regular grid sampler. And you can find always a description of parameters within this info graphic. And you can hover over and get the info, or you can double click on the info. You can double click on the graphic to make it bigger to better read or to better see the infographic. Regular grid indicates that you regularly sample a certain region, and yeah, this can lead into something like here, that due to the fact that the regularity is not sufficient enough, some areas will be not be sampled in a good manner. And that's the reason why the Poisson sampling is applied additionally. So they are always using the input points from the previous sampler strategy. So the workflow is mean point, regular grid, Poisson sampler. And then you end up in a pretty beneficial sampling of the region. And so you do not have to position those points manually by hand. They are automatically sampled in a way so that it's suitable. You can adapt all those parameters. So I wanted to increase to 1 × 1 millimeter, for example. And it would change a bit, but not dramatically. So all the parameters can be changed, and you can save the new profiles. The rods are normally looking like that. So those are tubes, and on the top of the tube, a cone-like structure is applied. Why is this the case, or why is this beneficial? With this cone-like structure on top, you can easier remove the support structures from the geometry, and you can adapt the cones pretty easy. Again, infographic. By increasing, for example, the scale, the tip scale, and the relative height will be increased, for example. Three. .3 and 2. So now I have generated another cone-like structure on the top, which is much easier to remove, but probably it's not stiff enough. So that's always the tricky thing about supports. You wanted to have them as weak as possible or as less structure as possible, but it has to fulfill the needs of thermal conductivity and the XY stiffness. And what we are using is a tube-like structure. So those are hollowed tubes. You can change to different types of rods. So, for example, you can change to cross rods, which are more or less a cross. Or what you can also use is a solid octagon. Then they are not hollowed; they are filled. But you have to think about that. This increases the build-up time immensely because the scanner has to do much more movement. And from my personal point of view, it doesn't bring you that effort that you wanted to achieve at the end of the day, because a tube is also a pretty stiff structure in comparison to a solid rod. There's not a big difference in the stiffness of the structure, and it's much more beneficial in context of build-up time.